Hey friends, Miss Paraso here. This unit was full of information, so I wanted to make sure that you had kind of a guide to go through your review, because I know we're not going to get to all of it in class. So hopefully there will be a couple of videos in this series to just break it down by section here for you so you can check your work and also just to check for your understanding. All right, so my goal is in this video, I'm going to try to make it through problem 8, but we might just do these 4 and then kind of do small chunks that way. All right, so the first few sections, 1 through 13, actually deal with the Pythagorean theorem. I will have that on the board or on the test for you, but your job is to remember that with the Pythagorean theorem, what the A and the B stand for is that you're looking for that right angle. And the right angle, those two side lengths that form the right angle, are the legs of your triangle. And the C length is your hypotenuse, right? That's the longest side of a right triangle, okay? All right, so with that in mind, let's go ahead and make sure we pay attention to those directions too. It says leave your answers in square root form unless it's a perfect square, in which case you will simplify it. All right, so we'll go ahead and take a look at the first one. It's given you the A, B, C values, so all we have to do is plug it in. So it's going to be a squared, so we're going to do the square root of 14. Do not put it in your calculator. Do not estimate it. We're going to go ahead and do the square root of 14 squared plus the square root of 9 squared is equal to c squared. That's your first step. You do not need to actually calculate out the square roots, because remember, any square root number, all right, any square root times itself, it's the inverse operation. So for example, if I do, let's just do this one here that we will for sure know. Well, actually, we'll do this. Square root of 4, right? We know that's 2. So just to prove to you, right? Right? What is the square root of 4? It's 2. The square root of 4 is 2. What's 2 times 2? It's 4. Well, notice the square root of 4 times the square root of 4, it's 4. It's the same, right? A radical times itself is going to be just the number that's underneath the radical sign. Okay, so that's a shortcut, so that way we get the most precise answer for those ones that are not perfect squares. Okay, the other reason for this too, which we did a very, very brief intro to multiplying radicals, is, well, what's 4 times 4? It's 16. And the square root of 16 is 4. And that's going to be the case for any radical, right? If I do square root of 5 times the square root of 5, well, 5 times 5 is 25. And the square root of 25 is 5, right? So we can kind of skip that, right? Now that we have that idea that any radical times itself, it basically is undoing that idea of a square root, okay? So what that means is that the square root of 14 times the square root of 14 is just 14. The square root of 9 times the square root of 9 is just 9. So that's what that simplifies down. Now notice it's still c squared on this side. We haven't taken any actual square roots yet. So we do want to be careful there. So we're going to go ahead and finish simplifying this side. We get 23 is equal to c squared. So that means that my final step, I have to take the square root of both sides, and I will get c, right? Let's think about it, right? This is really saying the square root of c squared is saying what number times itself gives you c squared. Well, I can repeat that c twice, right? That's those exponent rules. And 23 is not a perfect square, so we're just going to go ahead and leave it in radical form. Right, and we don't have the units, so we're just going to say square root of 23, and just to play it safe, we'll say units. All right? Okay, so since we kind of recapped that, go ahead and pause the video and give 2, 3, and 4 your best shot. I will say I'm going to go ahead and erase my work because I kind of covered up number 3 here, but when you come back, let's see how you did. All right, welcome back. So I changed my mind. I went ahead and just did number 2 there, and then I wanted to make sure that it kind of walked you through 3 and 4, just to kind of highlight some key points. But hopefully if you're done that with them, you'll be able to, you can just kind of fast forward. and check your answer, or you can listen to the explanation in case you got stuck. All right, so number 2, you should have gotten the square root of 91. You can see my work here. Again, showing all of the thought process and how I got there. All right, when we move to number 3 and 4, we've been given a diagram. And in order to use the formula, I encourage you that if you have the diagram, label which side is which. What's A, what's B, what's C. And remember, the legs are always the ones that form that right angle. And so that way we can ensure that we're plugging in the right numbers. So my A value I can see is 8 squared. I don't know the B value. I'm going to put B squared. And I have here the 11, so 11 squared. And from there, now I can go ahead and do my solving. Okay, we'll go ahead and subtract 64 from both sides, and just because I'm running out of room here, so let's, what is that, 57? Yeah. Okay, and I want to do final step is take the square root, and we get that B. We're not going to do anything though with it because it is not a perfect square. So B is the square root of 57, and we'll just say, always play it safe, units long. Okay, all right. So now let's take a look at number 4. Okay, and we're going to try and squeeze it in here. Again, let's pay attention to what parts of the triangle do we know. All right, so there are my legs. They're the ones that form that right angle, and here is the hypotenuse. Okay, all right, so I'm going to move this over so I can just not have my work all crowded. Okay, so I'm going to go ahead and label this A, B, and C, and I'm going to plug in, so let's just do, this is number 4 right here. Okay, the square root of 11, remember, don't touch your calculator, just plug in exactly what's there. Okay, then it's plus B squared equals 2 radical 16 squared. Now, you have a couple of things that you can think about. I'm wondering, did anyone notice that, hey, the square root of 16, that's a perfect square? Option 1, I could go ahead and say, hey, this is really 2 times 4, which is just 8. So if I wanted to, I could go ahead and simplify this value right here, and it's 8. That's it. Okay? But maybe I didn't see that. Okay? And so I'm going to, and I leave it. All right? Option 2, we can apply what we know about our exponent rules, right? And those radicals. 2 times radical 16 times 2 times radical 16. Well, 2 times 2 is 4, and the square root of 16 times itself is just 16. And now we can go ahead and do 4 times 16, and we'll get 64. So just to kind of show you what I did, all right, just showing you your options. That first option is we simplified, and we did that. Right? What is 8 squared? 8 squared is 64. And if I do 4 times 16, I also get 64. So I'm getting the same value. Okay? Let's say both of those options were confusing you. In your calculator, now it depends on your calculator, so you just got to be careful. All right? You can actually go ahead and plug in the radical, but you need to put parentheses. So we're going to do 2, and then I'm going to hit square root. Again, imagine you didn't know it was a perfect square, square root of 16. Now, I don't notice my cursor still underneath my radical bar. So for my calculator, I have to hit the arrow key. Notice it's no longer underneath that bar. I'm going to close the parentheses. So I'm telling the calculator that I want to take this number, all of it, and I want to square it. And if I go ahead and hit enter, you'll see that you get the square root of 64. Or not the square root, sorry. We get 64. Okay, I can do the same thing with that radical 11. I can, again, I'll just put parentheses to be safe. There's not any other numbers in there, but better safe than sorry. Okay, so we're going to do square root 11. I don't want to be underneath the radical anymore, so I'm going to move my cursor, close the parentheses, and I'm going to square it. Again, we should be getting 11, right? Because a radical times itself is going to just drop that square root sign. And we do. We get 11. Okay? So we've seen it with the calculator. We've seen how to do it by hand 2 different ways. Okay, so just something to think about as you work through this. All right. Okay, so with that being said, let's go ahead and finish up our problem. So this is 11. This is still b squared. We did the math 2 different ways. We saw that this is going to be 64. We'll go ahead and subtract 11 from both sides. B squared is equal to 53. Take the square root of both sides, so that way you get b is the square root of 53, and we're leaving it like that because it said only if it's a perfect square, and this was not a perfect square. Okay, so there's our answer for number 4. All right, make sure to check out the other videos that go over the other sections.